Hi there, welcome here. If you landed here, you probably saw my social media post about this retirement calculator I built in Excel. This playlist is a full walkthrough how to use it, how to understand the finance behind it, and how to adapt it for goals that have absolutely nothing to do with retirement. There are 17 videos in this playlist. The first one covers the decision sheet, which is a starting point for everything. The next 16 are pure tutorials, one for each calculation sheet. No fluff, let's get into it. What this tool actually is. Most retirement calculators you will find online have one mode. You tell them how much you save per month and they tell you how much you will have done. This one is different. It handles 16 different scenarios. Because in real life, when you save money and when you need money are two separate decisions, and that timing gap changes your math more than most people realize. The whole tool is built on three Excel functions: PV, PMT, and NPER, and one concept from CFA Level 1 called time value of money. I will explain both of those before we touch anything in this file. The concept, time value of money. Here is the core idea. Rupees 1 lakh today is worth more than rupees 1 lakh a year from now. Not because of inflation. Even ignoring inflation, it is worth more because money you have today can be invested and earn a return. So when we talk about retirement, we are solving two completely separate problems. Problem 1. How big does my retirement pot need to be? Say you need 1 lakh every month during retirement. You will be retired for 25 years. What lump sum do you need sitting in your account on day 1 of retirement to fund all those withdrawals? That is present value calculation. Problem 2. How do I build that pot? Once we know the target, how much should you save every month between now and retirement to hit that number? This is a PMT calculation. Or flip it, you already know how much you are saving. So when can you retire? That is NPER or NPER. Every sheet in this file is solving exactly these two problems. The 16 sheets exist because problem 1 and problem 2 each have different timing, and that timing affects the formula. Annuity due versus ordinary annuity. This is a concept that creates 16 scenarios, so let me be very precise here. An annuity is just a series of equal regular cash flows. Your salary, your SIP, your rent, all these are annuities. There are two types of annuity. An ordinary annuity means the cash flow happens at the end of each period. Think of your salary. You work the month, then you get paid. Or a loan EMI. You have already used the money, then you pay at the end. An annuity due means the cash flow happens at the beginning of each period. Think of rent. You pay on the first before you leave there that month. In Excel, whenever you use PV, PMT or NPER, there is an argument called type. Type 0 means ordinary annuity, that is end of period, and type 1 means annuity due, that is beginning of period. Why does this matter for your retirement? Two reasons. First, your savings pattern. If you do an SIP on the first of every month, that is beginning of a month, that is annuity due. If your salary comes on 30th and you save after that, that's end of month, that is ordinary annuity. The formula is different for each. Second, your withdrawal pattern. If you want money from your retirement corpus starting from the first of the month, you retire. That is annuity due. If you want it from the end of your retirement month, that is ordinary annuity. Again, different formula, different corpus target. These two choices, savings timing and withdrawal timing, are what creates the 4x4 matrix you see in the decision sheet. What is the decision sheet? Let me walk through exactly how to use this. The rows represents when you save. Month beginning, month end, year beginning, and year end. The columns represent when you need retirement payout. Month beginning, month end, year beginning, and year end. Each cell in this table has a number 1 through 16. That number is the sheet you go to. So if you save every month beginning like a SIP on the first and you want your retirement corpus to pay you every month beginning, you go to sheet 1. If you save at month end and want withdrawals at year beginning, then you go to sheet 7 and so on. Let's say go to sheet number 6. Simply click the 6 here and you will go to that particular sheet. Each sheet has a backlink at the top to bring you back to the decision sheet. So the workflow is come to the decision sheet, pick your combination, go to that sheet and fill in your numbers. Then comes the rate of return input. Below the matrix, there is one input that applies to all 16 sheets. Your required rate of return per year. Right now, it says 12%. This single number feeds every calculation across the entire file. Change it here and every sheet updates automatically. That's by design. Now, how do you decide what rate to use? This is where the reference links comes in. I have linked to 4 benchmarks, Nifty 50 average returns for equity exposure. Historically, around 12 to 14% CAGR over long periods, but this is not guaranteed. Indian bond yields for debt. This is CCIL link, which gives you government security yields by tenure. Then comes SBI FD rates for most conservative end, currently around 6 to 7% for most tenures. Then gold returns. If you are including gold as an asset class in your portfolio, then this is for you. Your actual rate should reflect your asset allocation from each of these. If you are using a combination of each of these, then depending upon your weightage to each of these allocation, you must multiply it with your particular percentage. Suppose 60% of Nifty 50 and 40% of gold means you have to multiply this return into 60% of your corpus and this return, gold returns, into 40% of your savings amount. You can use that rate here. What are the CFA concepts that this particular project covers? For anyone studying CFA or just wanting to understand what this sits, where this sits in the curriculum, this tool directly demonstrates the following concepts. First, present value of an annuity, the PV function calculating your retirement corpus. Future value and PMT, the PMT function calculating required savings, and NPER calculating time to goal. Future value and annuity due versus an ordinary annuity, the type argument which this tool is built entirely around. Most textbook problems use ordinary annuity. Real life doesn't always work that way. Rate conversion. When savings are monthly but the rate is annual, you divide it by 12. When savings are yearly, you use the annual rate directly. Every sheet handles this correctly for its specific case. How to use this for other goals? How to use this sheet for other goals? Retirement is just the use case I built this around. The underlying math works for any goal that has regular savings, a target amount, and a deadline. A few examples like child's higher education needs, your dream home, your dream vacation, your SIP goal, and so on. This particular sheet can be tweaked to match those all needs. I will explain each of that in the upcoming 16 videos. What is in the next 16 videos? Each of the next 16 videos covers one sheet. No introduction, just a straight tutorial. I will walk through case A, case B, case C, the sensitivity table on the right side, and where to tweak the inputs for a different goal. All the input symbols here are each of the inputs that you should put. Pick the sheet that matches your situation. That's the video to watch first. The link to download this file is in the description. Thank you, and let's get on to the next video.